Okay, so how to work out the instantaneous value at a specific time after the current starts to flow, right? So when we learned this originally, we were learning about voltage. So we were talking about the voltage peak, so we can work out what the instantaneous voltage is, right? But this question's asking us for what is the current? What is the current that is flowing 10 milliseconds after we turn on the power if we have a 130 ohm resistor, 240 volts and 60 hertz, right? So the current part of it is a little bit of a trick, right? That's just Ohm's law. So we could do this two ways. We could work out what the peak current is and then do this equation, or we can do the equation first to work out the instantaneous voltage and then use that instantaneous voltage to work out the current. I'd prefer to do it instantaneous voltage because then I'm not going to get confused by using a different number in here. So work out the instantaneous voltage and then we just use Ohm's law with the 130 ohm resistor to tell us what that instantaneous current is. Does that make sense to everyone? Okay, so let's have a crack at that. So our formula for instantaneous voltage, sine time over period times 360 times the peak. So if we substitute in the values that we have, instantaneous voltage will be sine T over P is going to be 10 milliseconds, that's our time, over our period. So our period is worked out off the 60 hertz, right? So 60 cycles per second. So our period in milliseconds will be 1,000 because there's 1,000 milliseconds in a second. 1,000 divided by 60. Could somebody just quickly work that out on a calculator for me? Just write that up there. P equals 1,000 divided by the frequency. What does that come out to? 16.67. Now we just need to remember here that we're writing those in milliseconds. I could write them in seconds. It would be 0.01 divided by 0.01667. It doesn't matter, that number would be the same. So I can use milliseconds or seconds as long as I use the same for both. And I have seen that people have done that in the past, used milliseconds here and seconds here or vice versa. Either one is fine as long as it's the same. So we've got that. Now we're going to multiply that by 360. Is that inside the brackets in that formula? It is, yeah. And then we're going to multiply that by the peak. Now our peak voltage, it's not going to be the 240 volt, right? It's going to be the peak because that's our RMS. So it's going to be 240 divided by 0.707. Was it 707? 717? 707. Let's get confused. So our peak voltage will be 240 divided by 0.0707 because 0.707 is our RMS, right? RMS is 0.707 of the peak, so it would be peak times 0.707 equals the RMS voltage, but we already have the RMS voltage, so we're going to divide the RMS by the peak, gives us a bigger number, and it should be something like 380, something like that. Could somebody work that out? How much? We'll just say 339. Sorry, I was miles off. 339. So then we're going to add that in there, 339. So if we grab a calculator, my calculator is my phone, which is recording. Somebody else want to run through that equation then? Sine. When you hit sine in your calculator, it should automatically come up with brackets. Have you got that one? Nathan? Yep. So we just put this inside the brackets that come after the sine. Yes. Yep, so as I said at the start, there's two ways to do it. So we can work out the peak current and then use that there, or we can work out this with the peak voltage, and then use that voltage. We work out this gives us the instantaneous voltage, so it's going to give us the voltage that's present in the circuit at 10 milliseconds, and then we just use Ohm's law then to work out the current, which I think is easier. We could work out peak current first and then do this, but we'll do peak voltage and then just use Ohm's law. Negative 199. We'll just go negative 199. So it's a negative number. It's come up with a negative number because if we look at our sine wave, that means if our peak is 339 volts, we're going to have 339 volts here. And we'll also have 339 volts here. But that'll be a negative, right? So our peak here is going to be negative 339 volts. So what we're saying then is that our 10 millisecond value is going to be somewhere around here, negative 199. Which makes sense, right? Because if our period is 16.67 milliseconds, that means it's the time from here to here is 16.67 milliseconds. So our 0 point must be about 8.33. Oh, it is 8.33. So our midpoint is 8.33. So we've gone a little bit past there. So we're somewhere down on the negative side, right? So now we've got negative 199 volts. That is how much voltage, how many volts there is present in the circuit at 10 milliseconds. So again, that question asks for, as you pointed out, only current flow, which means that I now have to take that instantaneous voltage and work out how much current is flowing at that point. But that's easy. So that's just Ohm's law. So that's going to be I equals V over R. And in this case, our voltage that's present is going to be the negative 199. We'll just use 199. It doesn't matter. We don't have to worry about the negative. We're just going to use 199 volts, and our resistance is 130 ohms. So it's 199 divided by 130, which equals 1.53. We won't worry about the negative. We'll just erase the negative. 1.53. Now I'm pretty sure I've gone in and edited this question. So there's two answers. One of them is 1.53 and the other one is negative 1.53. Or I think I said it so it's like between 1.52 and 1.54 or something like that. But there is actually, I put it in there, so there's two possible answers. One's negative and one's not. I'm not concerned about that. The important thing is we're working out how much current is flowing. I don't care which direction that current is flowing in. Does that make sense to everybody? Do we have any additional questions? It's okay with that? Cool. I will upload this to my YouTube channel so you can go back and see it at any time.